I want to get through this first because I know it ran really long the last time, and we're going to go over a lot of the same things, and hopefully I'll be able to use the board this time.
So if I don't take notes, you got it?
Yeah. So I'm going to send out exactly what I'm going to talk about. So if there's any extra notes, I mean, I'm not going to make them on here, but you should be able to remember some of the things that I talked about, okay?
Yep.
I just want, and I'm going to, so anyway.
Stop.
Yeah, and the biggest deal I wanted to tell you guys is, to the end, write your questions down. So the biggest thing that happened the last time is, I'm not going to give advice.
That's what we like the best.
Not that kind of, not that, like, how would I say this? And we kind of got wrapped up in scenarios. I have to stress, there's Ann, the water is different. I can't give you, you can't tell me what's going to ask me what's going to happen at 5 o'clock on this day at this for you.
Yeah.
It's a liability, number one. You're supposed to learn the water. I mean, you can only do it by experience. I can't tell you much of anything. I can tell you scientifically, but when you get out there, you kind of have to use your knowledge. The best thing is, like, if you're on an OC1, how do you know where the water is going or if it's straight? Well, you look at the water off the front of the nose. If there's more coming out, like, I mean, your lines, you know, that's what they used to tell you. How do you sit in an OC1? Well, you can tell if you're leaning heavy because of how the water comes off the front of the nose. You have to really start to learn the water. You know, feel the water yourself when you're, you know, the biggest way to do that is in an OC1 or OC2. OC1, don't do OC2. That's like, that gets like people involved.
Okay.
No, I'm just saying, you know, okay, everybody rolling in now. So anyway, so what we're gonna do is, I'm gonna start this. I'm gonna go through just some facts about the water. God, geez, I feel like, I mean, like we got like 8 people, guys. No, I mean, it's just we'll just wait. Come on in.
Hey, how's it going?
Did you bring me some beer?
Oh, man.
You're the sweetest. That is like the highest octane beer out there. Is it refrigerated?
It is.
Do you want one?
See, she's excused. For being late.
I know. We want one. Is this the multi-pack? Okay, hold on. There's one in here that's less than the other. As I see, like, yep, there we go. Okay.
Bernadette, what were you saying about the water coming out the front of the OC1?
Okay, so when you sit in an OC1, if you see your nose at the very top, there's going to be 2 lines that come off of each side. You'll know how you're sitting if you're sitting straight in an OC1 or how the water's coming off. If you're, and I hate to say it, it's all God bless. I hope I almost brought one from home. Let's pray these words. After what happened last time, I almost brought my whole packet, but I forgot. I was halfway here. Oh, this one looks halfway good. Okay, so pretend like that's the front of your canoe. There's your water. There's going to be a line coming off the front here, and there's going to be a line. We're really getting caught up here. So let's say, okay. And so when you're in a canoe, and you're sitting straight in your canoe, and your canoe is balanced in the water, on a perfect day, this is going to, I mean, geometrically speaking, this is going to be the same. This is going to be right. So if you lean left in your canoe, you're going to see this line do this, and this line do a little bit more of this. So, and the same thing, so what you want to do is, like, when you're sitting in a canoe, and you're learning skills in an OC1, you want to watch how this water comes off here. And even when water's coming this way or water's coming this way, this is where you want to watch because it helps you sit balanced in a canoe. The more you sit this way in your canoe, the more that line's going to go to the left of your canoe, and this line's going to get this way. So watch that. That's kind of a good way for you to gauge how you are, you know, how well you're sitting in your OC1. It'll do it in a 2-man too. 6-man it won't do because you've got 2. I mean, that thing sits too heavy to do that.
Now, that would be ideal in flat water. If you're in ocean, choppier.
Yeah, it's not happening.
Okay, yeah. All right,
sorry.
so that's going to be very useful in flat water.
This is like where I'm putting my hand into the darkness.
No,
it erases. Okay, we're in business. I know, right, guys? We're already ahead of the game. Did you want that? Sorry, okay. All right, so I am going to go ahead and just give some facts here about water. I mean, reading the water, you know, and then at the end, like I said, so everybody who just came in, this is 6 pages. There's visuals in here too that you're not all going to be able to see. It's a PDF. I'll send it out later. So I'll go through it, but you'll be able to reference back to what we talked about here. Yeah, and he's recording. All right.
Always recording.
And I was like, hi. Okay, so first things first. I'm going to tell you about the water, things that you can find online, but then this is also going to culminate in how do you, when you are leading a practice solo, your own OC1, OC2, or 6-man, if you're a steersman taking out one boat, what do I do when I am planning a practice about the direction that we go, why we do what we do, and just some other knowledge. Like what do you need to do before you get on the water? Like the things that you should all be looking at. You just can't grab a canoe and go. So to start off, everybody knows that we have the East Coast versus a lot of other places. We have 2 high tides and 2 low tides. And they happen roughly every 6 hours and 12 to 15 minutes. I think it's 12 hours and some change, 24 minutes, give or take, depending on which way it goes. So when you're reading the tide, I use NOAA. If I just put in tide and my browser on my phone, the first thing it brings up, because I look at it so much, is the NOAA tide chart for Wrightsville Beach. And that is going to be offshore right here at our buoy, and that's going to bring your tide. It's not specific, so when I did We the Water, I took each of the stations all the way up. Like I had to open every single station and figure out what our tide chart was to figure out where the tide was moving in and out. So when you read the tide, you're going to see everything is in what we call, and this is just kind of when I just was in school. Let's just say I'm trying to figure out where Wrightsville's up. Canoes, hey canoe. And then here's like the grassy area, and this is kind of really important. So, and then down here we have this, which goes like this. So when you see water around here, it's always going to be at what we call like the mean, lower, lowest tide. So the lowest tide, the lower lowest tide is the lowest tide that it can possibly be. So there's also the high tide. We don't worry about high tide around here in the general respects that high tide is only flooding. High tide, when anyone gives a high tide line, it's what is going to happen, like 3 feet of, what we call it, it's like mean, it's like high, highest, and there's mean, low, lowest, and there's a water line. And you will always see our tide here on the coast done in the low, lowest, because it wants to know, how low can it go, and it's going to be the lowest. High tide is here, but the highest high tide is usually flooding. Highest high tide is usually always flooding, and we only see high tide during storms, storm surge, hurricanes, and so when you see MLLW, you'll see it beside all of our tide, and that is how tide is read on the East Coast.
So even a king tide is still not
Yep,
that high.
yeah. So if you're looking at any website, just make sure you're looking at the mean, low, and the reason I say this is because it's always done in 0. 0 is good, and so if you look right now, when you pull this up, I tried to do the tide starting on tomorrow, Friday, so that you can see what Friday, so it won't have today's. You're going to see numbers always a positive for the most part. So around here, you'll see like right now, like high tide is going to be at like, you'll see this number. And then you'll see like low tide at like I'm just going to throw this in here because I didn't look at, I think it was 0.38, I can't remember. So this means, and then here's your 0. And this is going to be your main lowest water line. I think it's MLLW. Okay, meaning that on our low tide is never going to go above the lowest it's ever been here, all right? But it'll be just enough above water. So our low tide will always be here, and this is like almost 4 feet above that. So what is this number? This number is the average low tide over the past 19 years. I mean, that's what it is. That's how they tell us what our lowest low tide is. It is 19 years of data, the lowest tide here in Wrightsville Beach. And so, and I think that was only through, it's like the 80s through, I don't know when they redo it, like the period ended in like 2021, but the next 19 years will come, and then the next, and I have no clue why they picked 19 years, don't even ask me.
Is that just NOAA, or is that most of the tide charts?
Most of the tide charts, yep.
Okay.
Almost all domestic United States tide charts use this.
Okay.
If you are like in GIS, like I am, it's NE something 88, and it's the National Datum something 88. They use that number, but publicized right now for the general public, they'll always use the mean, lowest, lower, and whatever that is, wherever that is, it's always going to be 0. And from that 0 point, wherever it is, we just call it 0 because we don't know what the bottom is, you know. From 0, tide is always measured from that number. If you see a negative, like a negative point, whatever that is, like so on king tide days, you'll sometimes see like a negative 0.0 something. That would mean it fell lower than the lowest. I mean, like it actually was a super low day. And sometimes like we'll see like I think the last king tide was 4.85. Like we rarely ever go above 5, but even a foot is pretty rough around here. I don't know what the record is, so don't ask me.
So like it says like next Tuesday is gonna be, it says negative 0.04.
Right. So that's gonna be
Okay.
yeah. So that'll be lower than the mean low water line. It'll be like just like right. You know,
Gotcha.
0.04 is an
Right.
inch, 2 inches. I mean, like yeah. So that's right. So you normally on our normal days we're gonna see. And I think the first week of the month, first or second week of the month is when we're starting to see these king tides. I think like the highest date was somewhere like the second week of this month, I think is where we saw the 4.85. So anyway, okay, that's just a little backward, like, you know, little data. Whenever you read it and you bring up the long, and you'll see it on here. I think I gave you one, so you can look at it. So when I pull up the Wrightsville Beach chart, I put in recent data for Wrightsville Beach, North Carolina. And you're going to see a high, low. Obviously, it'll have our water temp if you really feel like looking at it. But I always put, you can change the data. It'll bring you like the next 24 hours. I did Friday for you on this page. So you'll see that like Friday, 4:36 a.m., 0.37. But it's going to be high tide is 3.08. And that's all in feet above that 0 water line. All right. And so you'll see it never truly, you want to, you know, the tide is just, anyway, I mean, it's I'm just kind of giving so that you understand what that is.
And Bernadette,
what?
the higher the tide, the more the rush out, right?
The higher
The lower
tide.
the lowest,
Correct.
the more push against you.
Correct.
Okay.
Yeah. Okay, so
You can have a racing tide out because it's so high.
yeah, and
and then
it
it's
also
all
kind of depends on
sucked
what's
in.
under. Yeah, like yeah. Okay. So I'm just gonna see if I have any notes on that. Yeah. So this is pretty much anywhere there's navigational purposes. That's pretty much why the East Coast uses it. It's just simply the lowest of the lowest tides. That's what that is. It's the lowest of the lowest tides, and then obviously, yeah, NOAA uses MLLW. I just wanted to put that out there. And flooding is always represented when you see MHHW because that is over the mean highest tide, and that's flooding. You'll never see that when you're reading a basic tide chart, but you might be on the news. It might be getting ready to storm, and they might tell you that tide is, you know, what it is above the highest tide because that's a record tide. I mean a record flood type of thing. Okay. MHHW also, if you want to think about that, it's your normal dry line. It's it's where water. It's always dry. And the mean is average. Everybody knows mean is average. Just so everybody knows, I can use that word too because I know people are like, what is mean, median? Okay, this is average highest high, meaning dry line. It rarely ever gets wet above this line. So if you see this reported here, it's flooding. Okay, so if you ever see that reporting, and around here it's a hurricane. I mean, usually, or some other storm going on. Okay, sorry. Okay, and I want to make sure we don't care. And I threw a photo in here so you would know. Here's a tide chart, and then you can kind of see where it will show you where it's like the highest of the high, the lowest of the low, and the low, just so you can see kind of what that is. The reason I'm bringing that up is because when you're on the coast here, tide and wind are our two biggest things that have to do with anything. You know, when you're on the water, it's tide and wind. And so it's really important to kind of know what your tide is doing as well as your wind. So everybody knows here, I just want to make sure, you know how if it's blowing 5 south-southwest, does everybody understand what that means? Like if you're looking at it, and if it's a south-southwest wind, that means it's coming from. So I just want to make sure it doesn't mean it's blowing to, because I want to clarify because I think a lot of people get that. If it's a south-southwest wind, it's blowing from that you know, so what is south-southwest wind? So that's a north-northeast. Okay, yeah. So I think some people get that confused. They're like, oh, but the wind it's God, the wind changed. And you're like, no, I just think you're reading it backwards. So I want to clarify that. So when the tide is falling, it's called an ebb tide, or falling tide, or the tide is going out. That means it's decreasing. All right, cool. And a flood current, like so, that's a high tide. That means the tide is rising. Okay, so we're going to go ahead and then. And so what is slack tide?
What is what?
Slack tide.
Slack.
When we're out there and
Slacking.
someone says it's like slack tide, what does that mean? Does anybody know?
An hour
When
before.
it's right. There is no change. It's basically where the two tides, and usually your slack tide around here, it's muddy. Like when you're out there paddling, it's like paddling mud because there's a little bit of pull and push, or there's no movement. It's like where two tides are coming together, and it's not like at a point. There is no line that is drawn out there. You are in an area where it's slack tide. And so if you are paddling, and so let's say high tide was at 8 a.m. and your low tide is at 2, that means your slack tide is going to happen somewhere around 11. And somewhere around in there, you're just going to have really no movement whatsoever, and depending on where you're at on the water line. So just want to make sure everybody understands that. All right, cool. When you get this PDF, there will be, I did put the link on here for the tides and currents so that you could just, I think it's already the Wrightsville Beach one. You can bookmark it in your phone if you want to, and it'll pull up. So next thing we're going to talk about is, because everybody really loves to go outside, but I've noticed that sometimes people don't know how to read the water outside. Outside for us meaning going outside the jetty. And I want to make sure, because we don't want to get out there and be like, oh my God, I didn't know it was going to be like this today, or whatnot. You should know what it's going to be like, because it's not, I just think we don't sometimes know how to read swell. And so I think I asked this last time, what does a 3-foot swell look like? And I always like to use 3-foot swell because it sounds so easy. Does everybody know what a 3-foot swell is?
It's like a medium size.
Well,
From behind, right? Not from the front.
right, so a 3-foot swell, if you are thinking about it, and in Hawaii they call it like the Hawaiians, it's like the face of it. So you've got this, and so here, if you've got this, and then you've got this trough. All right, so if this is a 3-foot swell, okay? And so here's your 3-foot swell. So this is a 6-foot face.
6 foot.
Okay.
And where's the boat? Just for reference.
The boat is here.
It's on land.
But somebody said from behind. That the swell is from behind.
Yeah.
Well, no, yeah, but what he's saying is
That's
like,
where
so
you
3 feet, yeah, so yeah, it's measured from behind is what we're saying. So I'm saying
the
that,
boat, okay.
yeah, so if you're reading, and when we get to it, I'm gonna explain what this chart is. I love this chart. It's on, I think I had a page of it last time. Some people took it home. Wait, I think I gave you a big one. So, it's this right here. It'll have the wind on it. It'll have what your face is. It'll have everything like that. And see, it even has little pictures. So you can see small little waves, and then you can see like the big waves. Okay? And I'm going to give you the link to this right here, because it pretty much has the tide on it. It has the wind. It has the direction you need to go. And sometimes I just need I walk outside, wind's not blowing, I could care less. I just want to know what the tide is if I'm just running a practice inside. But if you decide to go outside, there's just a lot more that you need to know.
So when the swell, if you're in your OC1, in that scenario, and you're going into the swell, you're going into 6 feet.
Yeah, well, yeah, like,
Yeah.
and so, and I'll get to like some pictures of that, but yeah, like the reason I brought this up is if it says 3 feet,
why it
you
feels so
probably
overwhelming when you
shouldn't
get
be
out
out there. Okay, that's what I say. Like, so you should probably look if it says like 1.5 or 2. That would be 3-foot faces. And if you want to be honest, I mean, a 3-foot face, if you're coming off of it, there's other things to look at. And I'll tell you guys, it's not just about what the swell is. The swell can look like this, and it be super awesome because you have a 3-foot here, and then here's your 6. Okay, excuse my waves. Or you have a 3-foot here. Sure. Okay. And the difference between these two, does anyone know what the difference is? There's one word.
Period.
Period. So the difference between this is period. This means if this is like a 10 seconds, this is probably like 2 to 3 seconds. All right, anything under 10 is what they call like a short period. Anything over 10 is a long period. When you're in your OC1, or the OC6, we call these rollers. This is a roller here. It's a nice rolling, and obviously we haven't thrown wind into this, so this is just, normal. This is a roller. This is choppy. These are actually, you might not think so, these are what we call inconsistent. Like they roll in. There's no every 3 seconds, every 5. It's just a long roller. These are more consistent because they're closer together, but it's super choppy. This is great for surfers if they're sitting out there, but not as much good if you're trying to hit. I mean, if you're trying to surf swell in an OC6, this is not going to work for you unless everyone in your boat knows exactly what they're doing. Because what you're going to end up doing is the nose has to be able to catch each of those tops. But what you're going to end up doing is sometimes going into here, the boat down, while this swell is trying to push up, and you're going to be going right, left, sideways, and people don't know how to hit this. It's really hard to do. This is easier because the boat picks up, and when it drops in, it's got a great push before it gets picked up again, and it drops in. So people love rollers because if you can hit a roller just right, it pushes you into it, okay? I mean, so that's how that goes. You're really getting away from water, but that's okay. All right, so, okay, so we just talked about that.
Good shit.
Okay, so another thing, this, and I actually looked up this definition because we talked a lot about this in my GIS program this year. People say swell, people say waves. We know that they are two totally different things. So I want to stress that swell is, and I'm going to read what it is. Well, I can tell you, swell is offshore. Swell is an offshore phenomenon that is smooth. It's usually a very smooth top. It comes from, Africa. It does. It does. Especially around here. Think about where our hurricanes come from. These are long. They start off very long, and what happens is it's very deep where they start, and their energy is from the water. Wind doesn't direct these. It is a current of the atmosphere, the magnetic pressure that just pulls them towards us. As we lose, as they come towards shore, and here's the beach. Pretend like this isn't right, so stop now. Pretend like we're at the beach. And this is pretty deep out here. We have our shelf. All right, and as they come closer, they become shorter, and they come together. And so what a wave is, especially here at the beach, is dictated by wind, by period, by the direction it's coming. It starts to have anything that's going on. Whatever is going on in the environment here is what a wave is. So that's why you'll see if it's really windy, waves will be choppy. If it's smooth, waves. So a wave is dictated by local phenomenon, local occurrences. Okay. So basically, swells are offshore, caused by an offshore distant origin, low frequency. They really are low frequency. Energies from the ocean floor, they don't need any wind, height, period, duration, it's all consistent. That's just what happens. So swell, it's greater the wind, larger the wave, longer the duration, the larger the wave, greater the distance it travels, the longer it comes in. So now when winds are blowing locally, the stronger the winds, the higher the waves, the high frequency, energy from all shores. So that's what you get. So you get direction, everything like that is what we call for the waves. And that's depth, contour, tides, all dictate what the waves we're getting here. So I'm not going to worry about any of the next stuff. I have little pictures for you here. Swell, waves. Swell, waves. Cool. All right. And I just did it so just so that you would know. All right. So everybody wants to go outside, and they need to understand. So this is the trough here. And so what happens is how I also am going to put in here. So kind of just how you measure. So everything was offshore buoy. I think if you were in the last class, it was the buoy right offshore. Yeah. It's there for a reason too. It measures. It's consistently taking. And how do we know that it's a 3-foot swell? Like how do we know? Well, in a 24-hour period, it's taking the average that passes by that buoy. So and it's what they call it as a day period. It's dictated by 24 hours. So every 24 hours, there's an average that's taken. And it's usually the top average. They don't care about little. They want to know what the highest wave was. They want to know what the average wave was. And it's usually, I think, the top two-thirds. Top two-thirds of all waves are average, or top half is average. And that's how they know that's 3-foot swells. And there's going to be, if you're reading the swell chart or the wave chart, you'll see that there's going to probably be 2 different lines. One is the shortest wave, and one is going to be the tallest wave that you'll probably get out there. And I believe they say that 14% of all waves are the tallest, the rest are the average. So you're going to have like an average wave, and you'll notice it when you're out there. Average wave, that they said, bigger wave. Average wave, bigger wave. About 14% of all waves will be what they call the primary, and then there's the secondary. So it's called a significant wave. It's an action, and it's really random. I'm not on the water enough, and unless you're a waterman, you probably don't see this. They say that occurrence happens like 3 or 4 times every 24 hours. And you'll have a significant wave, but the rest will all be an average of waves. So you'll notice that you can't just get out there and go, oh, it's all going to be 3-foot swells. That is the average of all the waves that are out there at the time. Okay, cool. Want to make sure, wave height, trough to crest. Oh yeah, I missed that, crest, sorry, trough to crest. So here's your trough, here's your crest, that's your wave height. Okay, so 3-foot, 6-foot wave face. That's your face. Okay, cool. Just some statistics for you that I'm not going to talk about. So we already talked about it, good, but we already went that. The period is the most important time. It's the success, it's basically the time that it takes for successive waves to pass the buoy. So a wave passes the, well, not the buoy, a fixed place, so whatever that fixed place is, every time a wave passes, that becomes the period. So that's how they do that. We already learned that 3 seconds, I use 2 to 3, provides more chop than 10 seconds. I wrote that. So in theory, the smaller and farther apart, the smoother the ride. Yeah. Okay? The bigger and closer together, the deeper the trough, and not as much fun to ride if you can't link them together. Yeah. That was my little play on things, you can tell. So not worry about that. Okay, direct.
Any thoughts on what's good? I mean, for you. I mean, when would you go out? To the outside.
Well,
what would you like to see?
I don't mind anything. Okay, anything under 5, don't do it. Like 5 seconds, I mean. Anything under 5 seconds, and I would say over 3 feet. Over 3 feet, just especially if you don't know what you're doing. And the reason I say 3 feet is because it's really hard. You don't understand what 6 feet looks like. I mean, here's 6, 6 feet.
Yeah.
So if you see it, I mean, it doesn't seem like a lot when you're on the back side of it, but when you're riding it and you drop 6 feet,
yeah.
You can't control you've got to be able to control your AMA, and if you're in a 6-man, you have to be responsible, that's a boat of 6 people, and you really hope that every single person in that boat knows what they're doing.
Yep.
And they know how to swim.
Right, exactly. So I love rollers.
Oh,
but I don't like them.
Yeah.
I mean, 10 seconds is a long time. I mean, it really is. It's a beautiful, you've been out there when it's just been beautiful. But sometimes, and you can feel it, like it's got that suction back and then it pushes you forward. I mean, and again, you also need to know how to ride them. And you need to be in a boat that knows how to ride them. Like the minute the nose starts to drop, people need to know how to apply pressure. You don't go faster, you have to go deeper into the water. I prefer anywhere, I think that between 5 and 8 seconds as your period is really good. And anything under 3 feet, now anything under like 1 foot kind of gets cruddy. I mean, there's not much to ride, but it's safe to go outside. I mean, like if you've got a group that's just paddling around and whatever, anything. We're like at 1.5. There are some 8s out there, I noticed, so just watch. Yeah, there's going to be some crazy wind. I think tonight or tomorrow there's going to be some strange stuff. But yeah, I would definitely watch. If you're going outside, make sure that you're under 3 feet.
So what about the 2 to 4 feet? Like I'm looking at swell info right now. So
what they do,
1 to 3 feet's easy. That fits right in.
Yeah,
there.
and 2 to 4. So they like to give you an average like that because you've got the significant wave and then you've got the lower wave. So you're gonna have probably what?
Like if it was high winds, that'd be crap.
Yeah, I wouldn't do it.
Okay.
Yeah, so when you see 1.5 here, people
3.
go whatever. But if it's 1.5, that means it's a 3-foot face, and if it's every 5 seconds, I'd do it. Because that means you could catch something. Actually, if it was even just a little bit less than 3 to 5 seconds, you should be able to pick that up and get a good push on that. Strangely, I know exactly. So right now, so you see, and there's I put this app on here too because I actually like to see it because 2 feet choppy. like this little guy tells you. I mean, like, you know, choppy, don't do it. Like, yeah, he's got good stuff. Like, yeah, he's like, this is the green area. He's got choppy. He's got bad. 2 feet, choppy. Yeah, don't do it. So, and I put the website so you can figure out what that is. Okay, cool. Let's get back into this. Nope. Okay, direction. So the direction of a wave is the origin. It's not the direction it's going. Just let everybody know. So if the and I think a way for you to remember this is, well, I mean, on the West Coast we used to say this, but think about a north swell in Hawaii. We always knew what a north swell was. A north swell means it's coming from the north, and that means that all north-facing beaches will be exposed to that. So a north swell does not mean that it's going north. It means, you know, it's going the opposite direction. So just want to make sure that if a swell, and most swell charts will tell you the direction that the swell is coming from.
So that's why in the news they always say southeast winds
Yes.
from.
Yes, so and the wind and the swell can be going 2 different directions too. Our swell usually comes what we call a longshore drift. So our swell does not usually hit us straight on. Our swell here usually hits us at an angle and it carries down. So if you'll notice when you come around the buoy a lot of the times, when you're coming around the buoy, you can rarely ever surf straight in. And if you were to, most of the time it's taking you up the north, or it's taking you way south towards Carolina Beach, and you almost have to stair step it this way or go this way. So a lot of times if it's heading up towards Johnny Mercer's, you have to come around the buoy and head this way really quick so that you can surf it that way in if you want a line. Or if you're coming around it and it's going this way, you've got to be able, instead of going that way, you've got to be able to almost take it a little bit and aim for usually the right-hand side of the jetty. And come around that corner right there. So you will never, I mean, I'm going to tell you, I don't like to say never, 99.9% of the time you will never come around that buoy and go, swell. It just doesn't happen here.
Right.
The way our shelf is and the way, I mean, even on a no wind day here, your swell is going to be going 1 or 2 of the other directions. So the best way to do it, if you want to line yourself up, you got to paddle out into it. Don't worry about the buoy, so that when you turn around, your set is, you know, exactly the direction that you want to go. Okay, cool. Yep, we already know that greater the wind, the larger the wave. Duh. Longer direct. Okay. All right. So, and I know that you might talk about this later. Cool. What is a small craft advisory? Does anybody know? I mean, does anybody know what a small craft advisory is? You see it on the news all the time. What is a small craft advisory?
Don't go.
Can we?
We're definitely a small craft.
Right. Well, small craft means, okay, engine. So you are a man. Yes. All right. So a small craft advisory is anything under 24 miles an hour, over 24 miles an hour.
Okay.
Gust, not sustained. And so I want to stress that it is a gust. So if you go to Surf Check and you see what's been going on and it tells you what's going on right now, but it says what your gusts are, that's a small craft advisory, and I would highly suggest that you not take a canoe out during a small craft. If you do it on your own, but don't put anybody else in a jeopardy, or stay inside. I mean, resistance training inside is fine, but you definitely need to be smart about when you go outside the jetty here. It becomes a little bit of volatile. So I just wanted to make sure everybody understood what a small craft advisory was, because a lot of people go, well, when do you cancel practice, or why don't you? Okay, well, number one, it's just not about me. So when it comes to practice, it's really just not about me. I mean, you've got to think about, all right, how many people do you have? What is the overall high and low of the experience level in your boat? And is everybody going to be able to do a sustained practice of 15 miles an hour? No. Most of those people won't show up. I'm just saying, like, you've got to remember because that's a painful practice to do 15. But if it's gusting 15 and it's only 10, there's no reason to really cancel practice. But you got to be smart about what practice is then. You got to be smart about where you're at. And that's where everybody's like, how do I decide a practice? And this is going to go into OC1, OC2, as well as OC6 for everyone. I take 4 things, well, I do 3 things, and then this is what, so wind is my number 1 thing. I don't really care about tide. Tide doesn't really matter. Tide only makes me dictate which direction we're going and how boring it's going to be, or how, you know, I mean, that's really it. You know, that's all tide does for me. If you go outside, you need to know what your surf looks like. Number 1. Number 2. And number 3, so it's basically wind, surf, and tide. That's where I start. So I always look at the wind first, and then I always look at the surf if we're going outside, and then the tide. So rule number one for me on tide is I always start with the hard tide and end with the easy tide. So I think I drew this the last time, and I'm gonna try to draw it again because I know that Barbara had some questions on it when we did the last time. So we're gonna do my lovely drawing of Rights Beach again and see if I can get this one right. Okay. Actually, let's see. All right, so the shore. And then let's see. Practice. Okay, bracers up, bridge. Okay, and so we know this, we've got, and then we got the whole Money Island paddle. We're just gonna do it this way. There we go. Okay, cool. And this is like this. Oh, we ran out of room. Money Island really isn't that long. Okay, we need to give us a little bit more room to do this. Okay, well, we know it comes like this, and then it goes, okay. And then this guy is like this triple. And here we go. All right, Mason Bird. Got it. All right, so hopefully, this is my lovely drawing, guys. Oh, I'm way off, aren't I? Well, okay, it's okay. You guys, I mean, come on, we all live here. You guys can figure this out. Oh, lollipop. Okay, here we go. And then, this is very long. This is 2 miles here. And here's Mason's, okay? There. We squeezed all that into that. Okay, so sup. And then out offshore. Yeah, sorry. Okay, so when we start to practice, and if it is an incoming tide, if tide is coming in, how do I do it? I'm like, oh crap, tide is been coming in for a while. Tide will be coming in all of practice. Okay, so if tide is coming in all of practice, that means I'm always going to end this direction. I'll probably leave it in that direction because that would suck. I would always end the direction of the tide. So if tide's coming in, its surf looks good, it's a good time to go outside. I would probably start this direction. If I'm staying inside, I'll come like around this direction, I'll come around this direction. So if tide is coming in, that means it's gonna suck. Still gonna, suck. Here we go. But here, it's gonna get better.
Yeah.
So here, so remember, so if we do like a Saturday practice, it's gonna be crappy for a while, then it gets good. Because now we're with the tide. We're with the tide for that whole while, and now this is really bad. This is all not feeling good at all. And then push. Mm-hmm. And that's how, that's what it looks like if there's a, okay. On the opposite, I would go the other direction if tide's going, because if tide is going out, this is fast. We all know Lee's cut is super fast when tide's going out. So that's how I determine. I just don't get out there and go and say, hey, we're going to go out. So if tide is coming or going out, but we still wanted to do this, I would do this and then come back in this way. And go, because tide would be, it might not feel good here, but it would still be a fast end. I just think it's brutal ending your practice on something that doesn't feel good. So in a perfect world, this works 90% of the time because a lot of times we have a slack tide. Tide's changing in the middle of it. But you definitely need to know where your tide, where it's going. I dropped it into the abyss, didn't I? Okay. Where, how tide affects us. The biggest places that tide affects us here in Wright School, this guy right here is more affected than this guy. Mason's it's very shallow, especially right now, as we all know, so it's not very fast. Like tide doesn't move fast here at all, but you notice that tide moves fast here because there's the inlet here, and what happens right here is we're paddling by. Before we even get up here, it's like a tide's going this way, a tide's going this way, a tide's going, whenever you get near to like here, or pages, here's pages, you've got tide coming from every direction, so it kind of gets mushy. But the biggest thing about here is tide's going to be always tough here. Tide's going to always be really tough here. So it's like, and the reason why is, again, it's got a lot going on here. It's shallow here, so this one gets a little muddy. Tide is, in here it's going to, sometimes be a little cruddy. But tide, if you do it right, your tide is always going to be okay here.
Excuse me.
Yeah, no worries. Let's see. Sorry.
Sometimes the guys would tell me when I was first learning the tides that, the tide would be behind, or it'd be behind the tide change on Banks Channel a little bit, or Lee's Cut.
Well, okay, yeah, so yeah.
And I
you
always
gotta-
wonder.
Yeah, so yeah, tides are never exact. So tides are always.
How do you account that
So
in?
tides are at the buoy. Well, around here we're an hour behind usually.
That's
Like
what you
yeah,
said.
usually about an hour behind tide
About
line.
45 minutes?
Yeah, you can think about it. I mean, it's not exact science.
Yeah, it's not. So sometimes it's 30 minutes.
It
sometimes
creeps
it is
in.
an hour.
When I lived on Pages, I could tell you that it was about an hour and 5 minutes. I mean, I could, high
Really?
tide would be at 9 a.m. and I'd still be paddling for another hour. I knew I still had an hour to give.
Yeah.
You know, if I wasn't back on time, I still had that push coming home because the water has to creep in. Remember, a slack tide, water's not moving. And so if you've got tide, so tide's going in. You know, tide's going in, and if it's, say, okay, let's do this.
Is it the same for banks and lees?
I mean, it really depends, and it's all about distance.
Okay.
So here's the deal. Here's your entrance to your water. Here's, you know, for us, you know, water only comes in here. The next place is Masons, and then down here it's Carolina Beach. So what happens, and we all know that tides are lunar. You know, it's a magnetic pull is really what tides do. And where it could be, and they dredge here, you know, so it depends on the depth, you know, tide, and you know, okay, no, we'll get, okay, I'm gonna make myself a little nice here, because I'm gonna mention this, because I know someone mentioned this the last time. So here, tide starts coming in, and at 9 a.m., tide isn't fast, because it's meeting, like if it's a high tide at 9 o'clock, I mean, it will tide change, like, so tide is high, let's say it's 9 a.m., tide's high, that's a song. It's like, what is that? I was like, wait a minute here.
Number one.
Oh, look at you guys. Okay, so you're paddling and it's 9 a.m., so tide's high. Tide doesn't immediately change and go out, right? I mean, it doesn't. It's got a little bit of time. So right here in the middle is where that slack time was. Okay, so 9 o'clock, you're over here at the buoy. What happens is, as the water starts to pull in, you know, the water's moving, and it starts to move slow because it's fighting a tide. I mean, like, it's not moving. But as the tide starts to go, like, a tide is rarely fast right on the hour. It starts to move faster as the tide gets closer to its high tide. So that means like at 4 a.m., 5 a.m., let's see, 6 a.m., did I do that right? 7, 8, okay, so yeah, so 3 a.m. Okay, so tide's not moving as fast here because it was low, and tide starts to move a little faster, and now it's moving a lot faster, and so now, because it's pushing, now it's got less resistance because there's less water going a different direction, and as you get closer to the high tide, more water has turned, it's moving the other direction. So this is the highest tide, is right before the change. And you know, I mean, you know, this is when tide is usually the fastest around here. So when you're asking about how tide changes, if high tide at the buoy is 9 a.m., water still has to move. Like, this water just doesn't stop. It's still all moving. It's still all moving. So that means it might hit right to what's up, and see here it's going this direction, and it's going this direction, and so it's all still moving. At 9 a.m., these guys are still moving in. So usually once this starts to pull out, this right here, 9 to 10, 11, this stuff still going this direction. So now it's like, it's that slack time where it's got to stop, and then it's all got to start going. So tide's already started to go out, and it's like slowly, it's like the telephone, you know, when you had the kid with the telephone, and this person gets the message, and then this person gets the message, you know, the little game.
Oh, the game.
Yeah.
It's already different by the end.
Right. So like this water is still moving. Like, water doesn't all do this, and then immediately all do this. It's like it starts. So as this one starts to change, these guys are kind of still moving, and it slowly all starts to make that change. That's why tide change, the farther away from the points of tide, or, you know, happen later. That's why the Cape Fear River, I mean, you're going up the Cape Fear River, tide change is it incrementally goes different. If you pull stations up the Cape Fear River, they are all at different times. Even when we were doing We the Water,
is it literally
same thing.
away from the buoy?
Yeah, I think this is where they run our tide, is from this buoy.
Okay.
Yeah, our tide is done at the, you know, I'm pretty sure the Wrightsville Beach tide is at this buoy. This is our station. So there's stations up the coast. It might be this buoy. It's on the map. Like each inlet has, and actually there are stations kind of inside. When we were doing We the Water, there were some stations inside that I was able to tag as we went up that were like crazy. It's like almost like we hit it one day so perfectly that the tide just was always going our way because of how it just rolled over. And like it's like we were racing, you know, it's like that whole, great example. You're in a plane and you leave Charlotte and it's 6 p.m. And as you go backwards, it never changes because like the sun, like it's getting darker where you came from because the sun's going down, but it's not changing the direction you're going because as you head to the west coast, it's still daylight because that sun hasn't gone, you know, you're going, so as you're almost like outrunning daylight. It's you know, you're going towards, so that's kind of what's happening. You can absolutely, you know, continue this. As you go up, you could chase tide for a while, but at some point in time, it's gonna just slow and then start crawling backwards the other direction. So I think it just depends on how far you are away from each of the points. It's not this buoy so much, like Pages Creek is by the buoy outside of Mason's, I'm pretty sure. And then when you get up to Rich's Inlet, it'll be dictated, those, like Futch Creek will be dictated by if there's a station right there because it gets their pull. Like Rich's Inlet isn't getting the water from Mason's. And it's not getting Masonboro. It's getting, Futch Creek is getting the water from Rich's Inlet. You know, everything's kind of going in, like water's going in somewhere here, like somewhere here, and it's all kind of doing its own little thing going this direction. And then it's trickling up each of these, you know, creeks that go up the way. So, and it'll all pull in, and then it'll all pull out. So it just, I think it just,
and there's no perfect way to time.
No, you're not ever, I mean, even tide itself, I mean, you can look at like this morning's low to high and then the high to low, it's not exactly 6 hours and 5 minutes every single time. You know, it's movements of minutes because of daylight, you know, or the moon, thank you. I was talking about that direction. that big thing in the sky. Okay, so I wanted to say this. Someone asked me about racing too, and how you choose the water when you're racing, and that's why I wanted to bring this up. I think we talked about this the last time. So let's say you're doing the Money Island race for Carolina Cup. And a lot of people have, like, where do you, like, you know, so the closer, where the heck I keep, oh, there it is. I was like, can I keep racing it? It's almost, okay. So Money Island's over here. Okay, cool. And here, let's say where you start. And get rid of that so we know. Okay, so Rachel, what's up? Bridge. When you're, okay, whatever day, just, you know, whichever direction, who knows. So let's say on a low tide day, the thing that people have always asked me about is like, where do you go? Where do you cross? It's honestly, it depends. We all know that on high tide, it's a longer distance and a low tide, but that, you know, so a lot of people ask about what happens here, like where do you cross? You know, when you're coming around here, where do you go? Yes, it all depends on the tide, but in like here, I think a lot of people have asked me about this over here. This guy can get kind of crazy. Actually, even this guy can get kind of crazy. If you think about it, each of these places that gets kind of weird on us, even here, there's big sandbars. Like there's huge sandbars in each of these locations. And so that slows down water, that speeds water up depending on what tide is. But just remember, just because it's low tide doesn't mean that it's best to come around this corner right here really close. Same thing here, because water slows down. When you were paddling down the ICW, for instance, and you're going this way. Okay, so let's say tide's going in. Tide is going in. You should be, your fastest water is here. When you're with the tide, your fastest water is here. If you are going against the tide, your fastest water, so here it is. If you're going against the tide, here's the tide, but you're going this way, you shouldn't paddle down the middle of the ICW. I mean, you're screwing yourself here. If tide is going out, I think that was the wrong side. The tide is going out, and you're coming around this corner, the path of least resistance is nearest the shore. Because the tide doesn't change as much on your shoreline. Gotcha. So all your water, when tide movement is here. Tide doesn't just do this. Water comes together, and your fastest hot water movement is always in the middle.
Because it's deeper?
Are you leading these?
I just got it.
Yeah.
Are you? I don't know where you are.
It doesn't matter where you're at.
Lee's Cut and going left.
No,
Where?
it doesn't matter where you're at. It doesn't matter where you're at. When you have two shoreline, yeah, it doesn't matter. We're just on the ICW. It doesn't matter. So here's your water in the middle.
Yeah.
And here's land. Here doesn't really matter. What we're saying is,
And you're going against
if you're
current.
going against the tide, tide's going this way, and you're
So
coming
you're on the
around
side.
the corner, you should never paddle down the middle.
On the side.
It's gonna crush you. Yeah,
on the
because
side.
water, the outgoing tide, your water moves like this. It goes this direction. All that water, and does anyone know why?
Because it's deeper.
It's deeper.
Yeah.
Water is faster where it's deepest. And so if you're looking at it from the front view, let's just say this. Here we go, they dredge. All right, here's the middle, here's the ocean floor, or the ICW floor, it's, you know, whatever, they dredge it. So water's always gonna move at the deepest place. So if you're near shore here and you're near shore here, it's slower on both sides, okay? So if you are against the tide, get out of the middle. Because it's like having headwind. It's like adding insult to injury. So your slowest outgoing, here's your little guys.
Do you prefer a side?
No.
Okay. That's
But
what
you
I
do-
wanted
It
to figure out.
depends on the wind, right?
Yeah, no, that is true. Yeah, if you throw
No,
wind
but-
into it, I hide myself in the
Because
water.
I find the dockside side less resistance than the.
I think it
freewater
just
side.
kind of depends. It's all
Okay.
about looking at the water. Like honestly, it's just looking at what the water is doing.
Except
You're
on
gonna see-
where the condo is, you know, up, you know, the big condominium. You said there's always deeper on the side of the condominium.
Oh yeah, that's where the gas dock is.
Yeah.
Okay. So
Yes.
in that
Yes. Okay. Yeah.
instance,
So
you
if you're
always go.
yeah, we're right here. This gas dock, you're absolutely right. The gas dock here, I always take it here.
Yeah.
And then I think it comes out. There's those houses. These guys adopted a Jack Russell for me.
Oh.
That's how I know their houses. Okay, so when you come this way, and then you gotta get right. I
Are
think
you
there's
hugging the side on the condominiums?
yeah. So here's the condo, whatever that thing is called.
CC
Thank you. This is dredged right here.
Right.
Stay away from this.
Right.
Hug the gas dock.
Okay.
And here's the island in the middle.
Yeah.
Pretend like I put that island there.
Yeah.
It's there's a little thing here. This is big. This is pretty deep. So honestly, a lot of people have gone this way against that and then straight out, or some have gone over to the shore. I mean, I just cut it straight across.
Yeah.
I mean, just half the least resistance is straight through the middle.
When in doubt.
Yeah, when in doubt, just cut that thing. But yes, stay over here near Watts, the seafood, yeah, and the gas dock. It is dredged right there, and so again, it's all tribal knowledge.
Okay.
It's dredged. You
I
know,
tend to go on the right side.
yeah, I mean, here's our bridge right here. I mean, just think about this, you know, this guy. I mean, this is all man-made here anyway. I mean, like they dredge on both sides of our docks. And here, I mean, we know there's a sandbar here. There's that. Oh, don't do that. There's a sandbar here, and sometimes there's one like right here before that side. So it's knowing when to kind of stay around this because water always slows in short depths. I mean, like that's just exactly what it is. But what you're doing here is you're using this same concept. Water has slowed here at the short depth. So if you're going against it, that means the tide isn't as bad against you here as the tide is against you here. Now, you change it, flip it up on you, of course. If you're going with the tide, get in the middle. Get it. Just like, yeah, you want to be here. You don't want to be here and you don't want to be here because, again, tide is moving fastest in the middle and you want to be wherever tide is moving fastest when you're against it.
Is there a point where the trade-off, like if you're riding the tide, but the wind is against you? Because we had
Yeah,
that
we're
race,
2 for 2.
we
We're 2 for-
passed
You
somebody.
and I are 2
They
for
were
2.
trying to protect themselves from the wind, so they weren't taking advantage of the current.
Yeah.
We took advantage of the current, and I think that helped us in this particular scenario.
Yeah.
But I don't know, like, is
Yep,
there a point where the
absolutely.
wind speed?
Yes, I
Makes
actually,
that
wind
go
isn't
along
always
with it.
bad. I mean,
Yeah.
everybody knows Becky, she actually loves wind. I mean, sometimes wind can be great. If you are at a good place in tide, tide's always going to move you faster.
Oh, okay.
That water is always going to move you faster. If your boat is moving and you've got some good, you know, power in that boat, go with your tide. Tide is, I mean, like, it's just, if you got good tide, go with it. And so right before that high tide, you know, not even that, it's like the middle of high tide. Like the middle of, as tide's going in, if you're about 3 hours into your high tide, stick with your tide, no matter what your wind is, because it's going to push you. On the same thing, if wind is not, you know, if wind is with you and you're against the tide, you know, you got to pick and choose where you're going to sit now. Now, where is it in the water? Is it closer to one side or the other? Because sometimes you think you're protecting yourself from the wind, and you just ended up in like the mushiest water out there. So you might as well just suck it up and take the wind. Yeah, absolutely. And it is around here about figuring out. I mean, we know. I mean, if you can just kind of figure out your areas. In front of the Coast Guard, it actually moves really fast. Like these docks move super fast. If you can get a current right in front of these docks on the Coast Guard side, you'll be great. You get in front of the blockade runner, it is crap. It is just like, put on the brakes, you stop, you're not going anywhere. But then we all know bridge to bridge, man. If you've got a good tide at bridge to bridge, I mean, you can fly.
Yeah.
I mean, that's like the best water out there because it's so protected right in that area. Yeah.
The Bermuda Triangle.
It is.
I went down a whole mile per hour.
Oh yeah, it's great. It's great. Yeah, and so again, it really is. It's about number one, knowing where you are in your tide. You know, when you go out, knowing where you are in your wind if it's gusting, and then kind of and then just placing it out. I always just kind of, you know, I look at a map and I try to figure it out where we are in the tide. Are the winds going up or down? And that's how I plan, you know, the route.
Speaking in front of block